Alright, so example 5, again, find the limit. And again, I'm going to go ahead and substitute in 1 and 0. And so I substitute in 1 and 0 for x and y. I'm going to get 1 times 0 minus 0 over 1 minus 1 squared plus 0 squared. And you see that I'm going to get 0 over 0. Now, again, this is the first thing you always want to do. You want to substitute in. The second thing that you want to do is you want to see if it's approaching the same value through different pathways. All right? And then after you check, 2, 3, or 4 different pathways, and you're still getting the same value, that's when you want to try to use the squeeze theorem. Okay? You don't want to say, oh, hey, let's do the squeeze theorem. No, check your pathways. If you're finding that you're approaching the same pathway multiple times, and you've tried a few, then that's when you want to look at, okay, maybe the limit does exist, and then use the squeeze theorem. So what we're going to do now is we're going to choose a pathway that we're going to approach 1, 0. And so the first pathway that we're going to choose is we're going to choose along or across the pathway. Make sure I'm writing it, keeping echo. So we're going to approach We're going to approach 1, 0, because that's the value, along the x-axis. Alright, so we're approaching 0, 1 along the x-axis, and so that means I'm going to go ahead and use f of x0. And I'm going to plug in. So when I plug in, anywhere there's a y is going to be 0, and anywhere there's an x is going to be x. So I get x times 0 minus 0 over x minus 1 squared plus 0 squared. And so in this case, I'm going to get 0 in the numerator, x minus 1 squared plus 0 squared in the denominator, and I'm going to get x minus 1 squared. Alright, and now when I look at the limit here, if I have 0 divided by x minus 1 squared, I know, hey, I'm approaching 0. Alright, as long as the x value does not equal 1, because then it would be undefined. So for f of xy, we're approaching 0 as xy approaches 1, 0 along the x-axis. Now let's see about approaching a different way. So now let's approach one, 0, a different pathway. Now, can we approach 1, 0 along the y-axis? No. Alright, and the reason why is because 1, 0 is not on the y-axis. 1, 0 is right there, and it's not on the y-axis. So we got to figure out a different pathway. Well, is there a line that we can figure out that will cross that pathway? Yeah. Alright, so we're going to approach 1, 0 along, and now we have the pathway of y is equal to x minus 1. So that's our pathway. Alright, that's just going to be a line that's going to go through that point. And so that's how we're going to figure out how, different ways of approaching is by finding lines or finding different functions that go through that point. And those are different pathways. And so now we're going to plug in f of x minus 1. And we're going to plug in and we get x times x minus 1 minus x minus 1 over x minus 1 squared plus x minus 1 squared. Alright, and now we're going to go ahead and solve. In the numerator, we're going to get x times x, so we'll get x squared minus x plus 1 over and then we get x, or 2x minus 1 squared. When I look at the numerator, I realize, oh, hey, that's just x squared minus 2x plus 1 over 2 times x minus 1 squared. And then I can factor that and have x minus 1 squared over 2x minus 1 squared. And that's going to give me 1 over 2. Notice that now, since I'm approaching a different pathway, that limit goes to 1/2. And when I approach the same value, 1, 0, from the x-axis, I get 0. Because I have two different limit values, the limit does not exist. Make sure I highlighted that up here too. Alright, so now let's try another one. Again, first thing, plug in. Alright, when we plug in, we're going to get 0 squared sine squared of 0 over 0 to the 4th plus 0 to the 4th, which is just 0 over 0. So now what I'm going to figure out is, okay, I'm approaching 0, 0, but let's see if we're approaching from different values. So I'm going to go ahead and choose the x-axis. So we're going to approach this one 0, 0 along the x-axis. So that means we're going to have f of x 0. Alright, and so now we're going to just substitute in. So now we go ahead and we substitute in. We're going to get 0 squared sine squared x over x to the 4th plus y to the 4th. 0 over x to the 4th, and we're left with just 0. So when we're approaching along the x-axis, we get 0. Now, let's say, hey, let's see if we approach from the y-axis. Alright, so we can try that. So we're going to approach 0, 0 along the y-axis. Alright, and hopefully we get a value different than 0. Alright, so 0, y. And so then I have y squared sine squared 0 over 0 to the 4th plus y to the 4th. Alright. When I do this, the numerator's sine of 0 is 0, so it's just 0 over y to the 4th, which is 0. Because I got the same value, alright, that means that I should probably choose a different pathway to 0, 0, alright? I don't want to choose, I want to choose something that's going to go through 0, 0, that's not the y-axis, right? And so I'm going to try this, one, maybe even 2 more times, and hopefully I get a pathway. If I don't, that's when I want to use the squeeze theorem. And that's why I hate that that was, that example was put before this one, because I would really like to try, I've tried different pathways before I tried the squeeze theorem. Alright, so now let's do question 12. Alright, I'm sorry, I don't know why I said that. So now let's go ahead and try a different pathway. So we're going to approach 0, 0 along, and then what's a line that goes through there along y equals x? That goes straight through the origin. I could have chosen y equals x squared or x cubed, alright? But I'm going to choose y equals x. And so, approaching 0, 0 along the y equals x line, so that it's going to make my f of x, x, alright? Because now y is x, I can go ahead and substitute in there. Alright, so now that I have, now that I'm going to choose x, I'm going to go ahead and say x squared sine squared x over x to the 4th plus x to the fourth. So I have x squared sine squared x over x to, or 2x to the fourth. And then I'm going to go ahead and I notice, hey, x squared x to the fourth, I can simplify that to be sine squared x over 2x squared. All right, now I don't want to forget what values that I'm approaching, for the original. And so I can rewrite this to be 1/2 sine squared x over x squared. Now, if you recall, x is approaching what value? X is approaching 0. One of your identities for limits, so like if you recall, the limit as x approaches 0 for sine of x over x, that value is just 1. So when we're doing sine squared x over x squared, we're still going to have 1 because this is sine of x over x times sine of x over x. So therefore, I have 1/2 times 1, which is 1/2. Now I have a different, limit, and now I can say, oh, DNA does not exist. Again, you want to try a few before you try the squeeze theorem, all right? More than likely, this is going to be the case because, we are approaching, there are an infinite amount of ways to approach our point. And so we definitely, want to try at least 3 or 4